Lab 4 talks about a counterbalance valve. Yeah, the counterbalance valve is actually just a sequencing valve hooked up backwards. Let me talk to you about application. Now, imagine a lift truck. There's a hydraulic ram lifting that really heavy load. So I don't know what it weighs 1,000 pounds. Now, I have to say lower that heavy load as well. So if I were to ask the DCV to retract the cylinder with 1,000 pounds on it, it would just go wham, it would hit the ground really quickly. So how do I slow that down? Well, what I'm going to do is I'm going to study the pressure coming out of the cylinder during retraction, during when the load is pushing it down. That fluid coming out is going to be under pressure. And what I want to do is I want to put a counterbalance valve in there that's going to say, no, when it gets to a certain pressure, I'm going to close. So, and when it opens up and then closes, it opens up. So it's constantly kind of metering the flow to some degree, but this is not like metering, either metering in or metering out that we did in pneumatics. It's completely different because metering is just throttling the air or throttling the fluid. We want to actually put really accurate control into this, and we want to say, I want to study the pressure of the fluid coming out of my cylinder and only allow it to go at a particular condition. So if it's too high, I'm going to block it. So that's what's going on. So we're not metering, but it's kind of similar because we're controlling the speed. A counterbalance valve specifically is designed to deal with great forces trying to retract your cylinder or extend your cylinder as well. In this case, imagine a forklift that's got a ram pushing something up and it's heavy. When we want to retract it, we want it to go slowly and deal with those really high pressures during the retraction coming out. So let's hook up the circuit. Okay, first thing I'm going to do is hook up these guys, and then I'm going to do my drain. Okay, so I go from here to pressure. I'm going to do my tank. Got my tank. Now I want to hook up my drain. Kinds of things that I don't have to think about so much. I want to make sure I go to drain and not to tank. Big difference. Okay, good. So I've got that going on. Now I can go over to my schematic and actually start hooking it up. Okay, good. So I'm going to put this guy up here and we'll take a look. Now, starting from my circuit, as opposed to starting from A and working my way this way, and or then doing that and then building my V, I'm actually going to focus on the way the flow is coming out. I'm going to focus on what I'm doing with my flow. I'm dealing with my counterbalance. So I want to actually kind of build my circuit the way that the fluid is flowing, more specifically about what's actually happening. So let me just move forward here. I'm going to start my circuit from the outlet of this cylinder. I'm going to go into my counterbalance valve because the flow is going this way through my counterbalance valve. Before, when I had my sequencing valve, the flow went kind of the other way, but now I'm dealing with the flow coming out of a cylinder, not coming out of my DCV. So I'm going to start from here, and I'm going to go to here. And I'm going to take a look at my schematic and make sure that I'm doing everything right. So, building my circuit this way, it looks like the first thing I do is I go into a T so that I can read my pressure. Again, I don't like putting my T's here, so I'm going to put this guy here, and then I'm going to take a short hose coming out of here, and I'm going to go to my pressure gauge. So I've got that guy going on. I'm going to go to my pressure gauge, and then from there I'm going to go into my counterbalance valve. So I'm just going to take a look at this right now. I don't actually go directly into my counterbalance valve. I actually go into a flow meter because we're going to study the flow. We're going to see how it changes or how we can limit the flow. Okay, good. So from here, I'm going to go into my flow valve, which is actually over here. I'm going to connect this guy here. Then I'm going to do this. So I'm always careful about when I hook this up. So I'm not moving things around. I want to make sure this is secure. Then I can hook this up because I have to be a little gentle with this thing. Okay, good. So now that's connected. So I'm going back to my circuit and I'm seeing I have the fluid coming out of here. It's going to a T. One thing is it goes to here. The other is it goes to my flow meter. Out of my flow meter, it's going to go into my counterbalance valve, but it's also going to go into a T. So I'm going to get a hose here. I'm going to come out of my flow meter. Then I'm going to go into a T. Okay, good. Grab a T. coming out of my flow meter into a T, because my diagram says so. So I'm at this point here where I've got a T and I've got to go to two things. One is a check valve and the other is my counterbalance valve. I'm going to go right to my check valve. In this side, again, I'm going to the ball side of my check valve. So I'm going to come into here and I'm going to have this guy like this. Good. I'm going to go to my ball side of my check valve, and then from there I'm going to go directly to my counterbalance valve. I'm going to go into the in of my counterbalance valve because I'm hooking my circuit up the way the fluid is flowing. Okay, here I'm going to my counterbalance valve and I'm going into the in. Good. Now, out of my counterbalance valve, well, I've got kind of two ways of looking at this. I've got two things going on here. I've got an out coming out of my counterbalance, but I've also got the line coming out of my check valve. So I'm going to do both of them, and they both go to a T. Okay, so I'm actually going to do that. I'm going to hook this guy up here. I could put a T here, but I think what I need is a little bit more space. I don't want to stress any of my hoses. So I'm grabbing my T and putting this on here. I'm going to go back to my schematic and I'm going to say, where does all this hook up? Okay, so I can see that out of my T, I've got two lines. One is from my check valve and the other is out of my counterbalance. So I'm going to put this guy here, coming out of my counterbalance. Now, I've got a line coming out of here, and as we can see from the diagram, that just goes straight to A. So I'm going to use a short hose here. I'm going straight to A. You guys will get good at this as you go. I mean, this is already into further labs down the road. So you guys are probably experts already at hooking these things up. Okay, good. So now I've got my line coming out of here. It's going through all of my different components and it's going to my A. And I can do my V line. It's just one hose. Let's hook it up. To my cylinder, and now my circuit is connected. Now, before I start everything, I actually want to study my pressure, my system pressure. So I'm going to hook this guy up. You can do that first. I like to kind of do it last because that's kind of what I'm doing. I'm studying the pressure, so it kind of helps me to kind of remind me that that's there. So anyway, now I got this gauge here studying the pressure. I'm going to turn it on, but first I'm going to take my counterbalance valve and I'm going to turn it all the way counterclockwise, turn it on and see what happens. Okay, good. So here we go. So I'm going to make sure this is completely all the way counterclockwise. That's like this. This is in the center. I'm going to press start. Good. I crank this up just a little bit. Now I'm just going to see. Okay, I've got some pressure there. I'm going to turn this until I get 500 psi in my system. Now I can control my system. We'll see what happens. Okay, here we go. So, during extension, now retraction. Okay, so it's moving pretty quickly during extension and retraction because my counterbalance effect is not in play yet. So I want to put it into play. Now, it would be nice if I had a really heavy load on there, but I don't. But I'm going to crank this up and now we'll see what happens. Extension, retraction. Okay, same thing. I'm going to crank it up even more. Extension. Now watch this, retraction. It's not even moving. I got this cranked up all the way. So you can see the pressure in here is starting to slowly get down. Here we go. There it is. Now it's moving. So it's moving really slowly. Again, we're not metering. We're doing counterbalance. It's studying the pressure coming out of the system. And it's only allowing the flow to happen when it's below a certain pressure. Okay, good. So I'm going to do this. I'm going to crank this all the way in. As I release it, I'm going to release it kind of quickly, and we can see it jumps down to there. Now let's study the flow in this circuit. We've looked at changing the set pressure, so I'm actually going to extend it. Now I got this crank all the way in, so it's not even going to move. If it does move, it's going to barely move. Let's watch the flow rate. As I allow the pressure setting to be lower and lower, what's going to happen is that, okay, so now you can see that it's flowing, and I've got slight flow rate. I'm going to crank it up. Now it cranks up. It goes up really high. So we can see, I'll do that again. I'm changing my set pressure. So I'm saying, it's okay, you can now come out at this pressure. You can see I've got some kind of flow, very, very light flow. So it's coming down slowly. My load is coming down slowly. I'm going to extend it again. Now I'm going to allow it to come down a little more quickly, and we'll see the flow rate's pretty high. There you go.